Okay, oh, there it is. Show my novice at live streaming. In this video, I'm going to be talking about how to do simulation work on a 4-bar linkage. So, to start out, we actually have to make a 4-bar linkage. I'm going to make 4 independent parts. And then these parts are going to be used in an assembly to model the 4-bar linkage behavior. So, first we're going to start out with building 4 bars. Now I'm going to do this very, very simply. You don't have to put in a lot of effort into this. And quite frankly, I don't care as much about you being able to create a nicely dimensioned 4-bar linkage. That's not what I care about right now. What I really care about most is whether or not you can do the simulation portion. So now, of course, I cannot ever seem to. Oh, I'm going to show you the way that I would model the 4-bar linkage myself. Okay, so here I draw a rectangle. What I'm going to do is I am going to create 2 circles, basically on a line with each other. I'm going to click on this one, control click on this one, and I'm going to make them be equal to each other. I don't think I can make them horizontal, but I will make them equal so they're equal circles. And then I'm going to dimension the distance between both of these. So I'll click on the centers of both of them. I'm going to go ahead and set this at, we'll make this the ground linkage, and we'll make this be 20 inches. Okay, so that is 20 right there. Nice, good job, me. Okay, so now what I do is I set the distance between this and this to be 1. It really doesn't matter. This is just for looks at this point. And then I set the distance between this and this to be 1. Again, it doesn't matter. And I'm setting this up in a very specific way because I'm basically going to take this file and just edit it multiple times. Make this be 1/2 inch. It doesn't have to be huge. I will draw a center line that goes from the center point here over to the center point here, and then for some reason this, oh, it's already on that center line. Nice. So the issue that I have is that I still haven't dimensioned this side, which I'm going to set this at 2 inches. Or if that looks weird, it'll be 4. Nope, 2 inches it is. Lastly, I'm going to take this point, control click this line, and make them be coincident. Hit OK, and I have to do that over here. Keep doing that. If you hold down control and use the center mouse wheel, that's how you make that happen. Okay, so I don't know why this is still blue. It shouldn't be. Huh. Interesting. Oh, there we go. Okay, so I basically just have to set this point and this line also as coincident. And that will fix my entire drawing. Okay, so now I've got one linkage. What I'm going to do is I'll exit sketch. I'm going to extrude this 1/4 of an inch. And call that a good day. So this is going to be my ground linkage. So I go File, Save As. Oh, look, the last time I did this. Nice. Go into my folder. Go to SolidWorks. Save this as ground. Okay, so now that that's done, now all I'm going to do is I'm going to go in here, and because I so nicely define this feature, I'll edit sketch, change this number. I'm going to set this one to be my crank, and my crank is going to be 6 inches. Okay, everything else will adjust accordingly. So I just hit OK, exit sketch, it'll rebuild, then I'll do a File, Save As, and this will be my crank. Okay, now you will want to do some amount of work to make sure, according to I think Grubler's equation, whether or not this actually exists. No, it's the Grashof condition. He used the Grashof condition to determine whether or not it actually exists, because you kind of want it to exist before you do this. It's kind of important. But I know that this one will work, so I'm change this now to 16. Enter. This one will be my coupler. Exit sketch. And save as. And this will be my coupler. Although I'm going to have to come back and edit the coupler at some point. But now I'll establish my rocker, and here for my rocker, what you want to make sure is that your P plus Q linkage is greater than your S plus L. So here my S and L is going to equal to 26. So this linkage has to be 10 inches or more. I'm going to make my rocker also be 16 inches. So I'm not going to change anything. I'm just going to go ahead and hit enter. Click exit sketch. I didn't actually change anything. And this will be my rocker. Okay, now like I said, I will need to go back in and edit my coupler, so I'm going to pop open my coupler real quick. Because what I'm going to do, just before I even start doing any kind of changes, is I'm going to, well, before I put this all together and start meshing everything, is I'm going to add some positions where I can draw coupler curves on this. So I'm going to go back into my initial sketch, edit sketch, and I'm going to take this line right here, and I'm going to delete that line. Okay, now what does that do? Well, it allows me to, now I need to draw a shape up here that I can attach points to. And I will do that. So I'm just gonna, let's see, I'm just gonna create some kind of shape. Something like that. Hit escape. Hit escape. Well, just because I'm that kind of person, I'll take these two, make them be equal. Hit OK. This one's already parallel, so we have this nice shape. For some reason it's not updating right there. We'll give some smart dimensions. I want the distance from here to here to be 10, sure. And then I want this distance here to be, sure, 12. Why not? And that'll fix my shape. Now, I need to do one more thing. I need to add in 5 points. So I'm actually going to add in 5 points, basically in a circle around right here. So I'll start by adding a circle roughly here. I'm not going to really fix its position at all because it's kind of an interesting approach, I suppose. I'll give this a dimension of 1/2 inch just because I like a little bit of uniformity. I am, again, that kind of person. And then what I'm going to do is I will do a circular sketch pattern. I'll have 5 and it'll go about 90 degrees. So here I have the entities to pattern is going to be the circle. The point that it wants to do, I want it to be the center point down here. So I may need to actually define a point before I do this. So grab a line and I'll just quickly draw it right there. Select that line, make it be for construction. And now I have a point there that I can rotate about. So I'll try this again. Circular sketch pattern. Or you could just place 5 of them, whatever. Entities to pattern, circle. Don't want to do it about that point. I want to do it about that point. So it'll trace circle of about 5. Well, I kind of want it to go a little bit closer up there. Here, I only want it to go through 90 degrees. Whoa. That's interesting. I'll set it down here. That's interesting. Let's try -90 degrees. Oh, thank you. Let's try 90. Yeah, for some reason that shifts the whole thing. That's so weird. I don't know why it would do that. Fascinating. Oh, it's because I'm changing theta 2, not theta 1. Huh. Silly me. So here, it's across 90 degrees, it's putting down 5 different points. That's good enough for me. So I'll go ahead and hit OK. Exit sketch. And now I have 5 different points that I can track on my coupler. So I'll go ahead and save this part and create a new assembly. What I'll do is I'll mesh some faces to each other. 4-bar linkages are a little weird because you have to mesh the revolute joints together, and yeah, so we'll start by adding in the ground linkage. You want to add the ground linkage first because it's going to be a fixed linkage when you put it into your assembly. Here, I'll just drop it in. Before I do anything, I'm going to go into View, Display, and nope, Hide Show, Temporary Axes. And what that'll do is you can see that I can see my axis right there. That'll allow me to mate to that axis, kind of align my axes when I put in new parts. I'll go back into Assembly, Insert Components. I'm going to start by adding my crank. I've already got the coupler and the rocker open, so that's helpful. Start with this one. You know what, I'll just add all of them at once. Why not? Big fan of chaos. Okay, insert components, add a rocker. Okay, so now I've got everything put in place. I'll start by setting some mates here. I want to mate this axis. You'll notice it shows up as an axis right there with this axis right there. Whee! Hit OK. Now I want to slap this face. Select that face. Slap it on right here to this face. And there we go. So we're just going to keep doing that. So here I want this axis to be meshed now with this axis. Hit OK. And I'm going to slap this face onto this face and hit OK. One last one to put in. I need the rocker axis to be here on this axis. Hit OK. And then I need to take this rocker axis and mesh it with my ground axis down here. It's going to force everything to move. I hit OK. If you get an error there, it's because you didn't do your grash off check. I'll mesh this face now to the top face here, just to cement my 4-bar linkage in place. And that's all the mates that I need. Okay, now you'll notice right here it says fixed. If I right click on this ground link, I can force it to float instead of fixing it, but I want that one to be fixed because I don't want that to move. Here, woo! Oh, that's fantastic. No idea. Oh, there it is. There it is. Okay, so that's my linkage. SolidWorks is being weird today. That's amazing. Good job, SolidWorks. There's 2 different configurations you can have, and SolidWorks is bouncing between the 2 of them. I want this one to just be up. So now I've got it in place. What I'm going to do is I'm going to go to SolidWorks add-in. We're not going to do simulation today. I'm actually going to shut that one off. Take a little bit. We will be doing SolidWorks Simulation later on in the semester, just not today. But we are going to go down here to Motion Study 1, and here you can apply a lot of different features. What I will be doing is I am going to go into, I think this is basic motion, maybe? What you have to start out with is you have to start out by adding this thing, which is it's a rotational motor. So I want it to rotate here. I think this is about a point. I'll set it to rotate about this axis. And the part is going to be this one. Okay, now you can define this. I'm going to slow this down to about 20 RPM. And I want it to travel at a constant speed. Okay. Hit OK. So it completes a full revolution, 4.5 seconds. If I go ahead and hit play, won't do anything. Nice. Thank you. It makes fun noises. Yeah, it apparently doesn't do anything at all. So that's awesome. That's stupid. Back in here and edit this feature. That's the motor location. Okay. I can reverse the direction of it. I have it traveling at a constant speed. Should work. Maybe I need to switch this back to animation. Hit OK. I'll hit play. There it is. Okay, so it does have to be an animation. And there, look at that sweet, awesome gyration motion. Boom, chicka, boom, chicka, boom, chicka, boom. You only really need it to go around once, but this one apparently wants to go around twice. I am going to add in a separate entity, and here I have to basically add in a sketch point. I don't remember how to do that, so I'm going to start clicking stuff. 8 frames per second, nice. You can add gravity in, you can add motors, animation fun wizards. I feel like there's a plugin that I'm missing. Oh, the SolidWorks Motion add-in. Duh. So you gotta go up and add the SolidWorks Motion plugin. I know it was on the SolidWorks add-in tab for some reason. This is going to add a couple of fun tools. When it finally loads in, I can do a motion analysis. And that's what I want to do. So here I've already got my motor put in place. If I hit play, apparently it doesn't want to do anything. So I'm going to have to go back in and fix that. Nice. Thank you, SolidWorks. Oh, I still have to turn on animation, I think, in order to actually see it. Oh, it's dumb. SolidWorks. So go back in here. You can do a result and a plot. You can add in a damper, you can add in contact, gravity, force. But what I am specifically looking for is I'm looking to create a plot, I think, and create a new plot versus time. I'm not actually too certain about that one. I don't think it's a plot. You basically just track a point. Looks like a pen. Maybe it is an animation. Oh. I don't know. Oh, calculate the motion study. That's the button you hit instead of play. Yeah, nice work. Go back in here. I think you can... Alright. Grab and Google real quick. And track a point in motion analysis. Tracing a point. Assembly. Oh, thanks. Default. Property manager. Results in plot. So you do have to set up the results in plots, category, displacement, trace path. Okay. So go into my plots. Plot versus time. And hit yes. Select a valid result category. Oh. Oops. Here, I just want to displacement, trace path, and then I will select one of these axes. Or just the circle, apparently. Then I hit OK. And then I go down and hit calculate motion. I'll run through it, and it should give me a plot. At least I hope so. Fingers crossed. Results. There's my plot path. Maybe I didn't do that right. Select items. Calculate. Motion path is not plotted. Yeah, well, it didn't appear in the area. We have to hit animation. Maybe not. Yeah, for some reason it's just not doing that. Well, let's switch back to animation. Not doing what I want. Motion analysis. Feature. Trace path. It's supposed to just be good with that. I want it to show up. And then when I hit calculate, it doesn't move. It's possible that I need to redo my motor in the actual motion analysis category. So we'll redo that. Component direction, we'll select this axis again. For the actual component, pick this one, the rotational motion, set this at 20 RPM, and hit OK. Now when I hit calculate, it's still not moving. Maybe it'll move. Maybe. We'll see. It should at least show up. Well, that's the basic process of how to do this. My SolidWorks is being a little weird. I've shown you most of everything. Apparently I can't get my plot to work, which that's supposed to work, and it's just not. A little frustrating on my end. So I like to show it to you. But that's it. So that's your assignment. You got to do 5 of these. Hand those 5 in. Just take a screenshot right here of SolidWorks showing the path trajectories.